Good morning, ladies and gentlemen, and welcome to the VELOCYS PLC full-year results investor presentation. Throughout this presentation, investors will be in listen-only mode. Questions are encouraged and can be submitted any time via the Q&A tab situated on the right-hand corner of your screen. Simply type in your question and press send. The company may not be in a position to answer every question it receives during the meeting itself. However, the company will review all questions submitted today and publish responses where it's appropriate to do so. These will be available via your Investor Meet Company dashboard, and you'll be notified once they're ready for your review. I'd also like to remind you that this presentation is being recorded. Before we begin, we'd like to submit the following poll. I'd now like to hand you over to Henrik Wehrborn, CEO, and Andrew Morris, CFO of VELOCYS PLC. Good morning.
Good morning. Thank you for joining VELOCYS final results 2020 investor presentation. It's delighted to see the large number of interested shareholders, current and potential, joining us today. Very nice. Andrew Morris and I will go through a short presentation, 17 pages, with you today. That will take about half an hour, and we're going to open up for Q&A afterwards right away. VELOCYS, for those of you who do not know VELOCYS so well, VELOCYS is an FT technology. We provide FT technology enabling commercial scale fossil-free synthetic fuels for the aviation industry. That is the core of our mission at this point. We have been developing this technology for a long time, as you will see in a moment. We are an international UK-based sustainable fuels technology company. Our vision is to unlock low-carbon sustainable fuels to decarbonize aviation and heavy-duty transport. After 20 years of research and development, we are now here and now turnkey technology solution available, enabling full-scale production of synthetic fuels that are fossil-free. It's a fortuitous juncture in history that we are ready to deploy this technology at scale now, after having developed it for so many years. Our founders who started this endeavor 20 years ago had various other ideas of how this could be deployed, but now it has been a convergence between our ability and technology and what the world needs, which is quite fortuitous. Over the last few years, there's been obviously a stronger trend towards finding alternative non-fossil solutions for aviation. We've had British Airways as a partner with us for quite a few years. But over the last 1 year, many other airlines have woken up to the necessity of finding alternative ways of sourcing their fuel, but preferably not having a new type of fuel. That's where we come in. So we are, obviously, after all this work, we have covered and protected our technology very, very carefully, with a broad and deep patent portfolio covering all the major jurisdictions. So we are very sort of secure in our sort of infrastructure around our patents. The technology we have unlocks the utilization of abundant, sustainable, solid waste feedstock. So we'll come back to what exactly that is in a little later in the presentation. But it's very important to look at sustainable, abundant, solid waste feedstocks. We are today a revenue-generating business with an international client base. We've had our first few clients, orders, revenues, deliveries, completion. And we are future-proofed by being compatible in our technology solutions with the carbon capture, usage and storage, without which, frankly, not much industrial development is going to happen anywhere in any sector going forward. Flick to the next page. Andrew and I were both appointed into our current roles by some major shareholders on the board back in November 2018. We have refocused and transformed the company fairly significantly since then, including a singular focus on deploying the technology for sustainable, renewable fuels, and declining to working in the potential applications in the fossil sector, which the company had previously explored. So we are purely licensing our technologies for sustainable synthetic fuel production. What I think attracted both Andrew and me to the company originally was the deep bench of talent we have between our sites in Oxford, Columbus, Ohio, and Houston, Texas. We have some world-class leaders in their respective fields. This technology integration that we are offering as a solution to the global aviation industry requires a number of different disciplines and leadership and expertise in catalysis, in engineering, in feedstock sourcing, in manufacturing of reactors, and finance and legal, of course, as well as policy engagement. We have some incredibly talented people based in both the UK and US working seamlessly together in this mission. This next slide is a little bit busy, but it sums up the most important achievements over the last 15 months that as shareholders, I think you're all interested in. The reference projects that VELOCYS, even though we are a technology licensor primarily, and that is our long-term business model, in order to increase and accelerate the adoption of our technology, we decided with our shareholders and board a few years ago to develop and co-develop with partners 2 reference projects where our technology is deployed as the central processing unit. We were lucky also to have already from a while ago some third-party clients, but the reference projects are there to accelerate the adoption of the technology, showcase how it can be scaled up, and accelerated overall, and together with attracting policy incentives from the respective host countries. So the 2 key reference projects are, of course, the Alto project in Immingham in the UK, which we are developing together with British Airways, where we achieved some significant milestones, beginning with the very successful planning permission process that culminated in a planning consent by the North East Lincolnshire Council in May 2020. That was not trivial, not easy. It was a remarkable success in the speed and the near unanimous support from all the mandatory consultees. That was almost unheard of in the UK previously for that to happen in such a coordinated, well-executed, consensual way. The project is now feed ready. That means that we have completed all pre-feed engineering studies by Worley, one of the largest EPC companies in the world, and all the key licensors are engaged and involved and onboarded and know what they need to deliver. As many of you know, we have an active dialogue with the UK government around the necessary policy incentives to be implemented. The UK government have made a number of public statements strongly in favour of accelerating this sector of the UK even becoming a world leader in the business of converting waste cellulosic products such as MSW or otherwise into sustainable fuels. So we are in active dialogue with the UK government on what exactly it takes now in terms of policy support for such a project like Alto to be financeable and long-term profitable in this country. So that we are in a very good position there. There is policy engagement, formal consultations, informal conversations going on between us and our stakeholders and the industry in this sector right now in a very, very constructive way. And the support and partnership with British Airways could not be stronger. British Airways is extraordinarily supportive, helpful, constructive, engaged partner to have in such a project. The Mississippi biorefinery project in the US we have been developing on our own for some time. It is focused on converting residue products or waste products from forestry industry, which is abundantly available in the Southeast US, millions and millions of tons of it. Therefore, the project, the biorefinery for synthetic aviation fuel in the US can be designed and scaled a bit larger than what we can do in the UK. it's possible to, without any sort of side effects, have a aggregation of more than 1 million tons of feedstock in one place for such a forestry residue conversion process, while scale is slightly limited in the UK for obvious reasons. So we have re-engineered that project to aim for 30 million gallons per year, which triggers or generates an avoided carbon dioxide volume of 600,000 metric tons, which is a very significant number. And that is required, that kind of scale and size is required to meet investors and offtake requirement, and in order to unlock economies of scale to be able to generate a satisfactory expected internal rate of return. So that has been successfully now re-optimized and redesigned. There's been a very constructive and dynamic interplay between the project development and engineering work between Alto and the Mississippi project, in particular over the last 24 months since Andrew and I took charge, where we are using the same engineering company for both projects, which unlocks huge amount of synergies and learnings and acceleration. So as you're probably well aware, also the market conditions in the US for conversion of sustainable feedstocks into fuels have been dramatically improved over the last 9-12 months. The traded value of the so-called RIN credits, which generate a huge amount of the revenues for such a project, have doubled or tripled in value. The so-called under RFS2 policy instrument that has been in place for more than 10 years in the US have traded RIN credits for avoided carbon called D3 and D7 credits, which have increased in value from $1 per RIN to now 3.2 currently. It's a dramatic improvement, and all other RIN credits have also doubled or tripled in value, supporting various types of biofuels. And in addition to that, there's very strong policy incentives from individual states in the US, such as the California Low Carbon Fuel Standard, providing additional financial incentives for this kind of conversion and supply of synthetic fuels into California. Therefore, the interest in long-term fuel and credit offtake agreements has increased dramatically over the last number of months, as well as interest from partners to come in and help to finance the full feed, as well as the project itself in due course. So it's been a very sort of favorable development. And another very significant event happened last week when a so-called blender's tax credit bill was launched into Congress for sustainable aviation fuel, specifically dedicated to incentivize production of sustainable aviation fuel over and beyond renewable diesel. There's strong incentives in place already for renewable diesel, which has already had a very positive supply effect in the US, but next to nothing in terms of sustainable aviation fuel or renewable aviation fuel. So the additional incentives required in order to incentivize producers like ourselves to produce sustainable aviation fuel has now been launched, and that is very meaningful amount of $2 per gallon. And even though it's called a tax credit, it is a direct cash transfer from the federal government to the producer of the sustainable aviation fuel, such as the Mississippi refinery project, for example, which is proposed now, which will tilt economics in favor of aviation fuel rather than renewable diesel. Renewable diesel will still be produced via other technologies which are, let's say, less advanced and therefore, let's say, mature now and first generation biofuels. But these advanced type of pathways that we propose are favoring aviation fuel technology wise, as well as now matched with the right incentives in the US. So it's very encouraging. We expect that to pass through Congress relatively relatively swiftly. We don't know exactly how swiftly, but there seems to be reasonably strong bipartisan support in the US for such a scheme. Meanwhile, in Japan, we have achieved 1,500 hours of integrated conversion of wood chips to specification on-spec ASTM compliant sustainable aviation fuel. We completed, or our partners there on site completed, full catalyst regeneration in the field. A certain amount of volume of SAF was produced from the wood chips, and we expect that our partners in Japan will be celebrating that by using that fuel after it has been obviously fully tested, which has already been completed, for commercial flights. These are not test flights because it is on-spec industry standard fuel that has been produced. Therefore, it goes straight into the commercial system. There's not a question of testing a new type of fuel. That I can't emphasize that enough. We're producing an already accepted industry standard product that goes straight into the fuel systems of the airports, not for anybody to adapt a new type of fuel. That's very, very important and a critical advantage of our technology. So in the wings we have, or publicly and in the wings we have third-party clients already, of course, Red Rock in Oregon, who are progressing with their project. We have a number of other pre-feasibility work studies going on with other projects and that are looking to launch similar projects. And we have an announced collaboration agreement with Toyo Engineering to advance a full commercial scale biorefinery in Japan that was signed in February 21, which the purpose is for that to work with the Japanese government to secure a site and a project which is most likely be called NIDO 2, which is going to be a commercial scale biorefinery using all the experience and evidence that was obtained during the NIDO 1 demonstration late last year. I'm now handing over to Andrew to go through the 2020 results and a little bit more detail about our technology. Andrew, over to you.
Thanks, Henrik. As you can see, the financial results are set up there. I think these have been published and hopefully you've all had a chance to look at those. To date, we raised, as many of you will be aware, 21 million before expenses in July last year. And we had additional £500,000 from the F4C, as it's known as, Future Fuels for Flight and Freight, rather a mouthful, grant from the UK DFT. We're just about to receive the last piece of that funding shortly. The F4C actually was really to be invested into projects rather than into this stage. So there's potential for additional funds to come from the F4C grant at a later date once the project gets into construction. In terms of revenue, small amount of revenue, similar to previous years. However, we do have a significant, reasonable amount of revenue that is deferred due to the fact that the performance tests at Red Rock haven't actually occurred yet. However, we have delivered all of the equipment and loaded the catalyst into the reactors on site in Oregon. In terms of admin expenses, again, a little bit of a drop, 7% compared to previous years, with the operating loss again being 8.8, some 800,000 lower than previous periods. Cash at the end of the year was 13.1 million, which was kind of on target for what we expect to be spending. We've not had any unusual expenditure and don't expect any. We're working to budget on time. So let's move on to the next slide. I'll click the next one. In terms of, I can't quite see everything on this piece, that's better. Yeah, so in terms of who else is looking at what's happening in our sector, the World Economic Forum with McKinsey did a study published last year, in Q4 last year, which provided a tremendously strong independent validation of sustainable aviation fuel as really the main way of decarbonising commercial aviation. Aviation, if it was a country, would be the 10th largest carbon emitter in the world, at some 3% currently. Based on 2019 numbers, it was expected that air travel would double by 2037. and by then some of the other aspects of emissions would be significantly reduced. So air travel, commercial aviation will become a bigger emitter if we don't do something about it. And what we'll see from the combination of the slides today is that sustainable aviation fuel is the way to sort out this problem, and keep us all flying. In terms of why sustainable aviation fuel, or SAF as it's known as, it's essential for the Jet Zero ambition. It's a fuel that's available now, and it has things like 7 times the energy density than current state-of-the-art batteries. The great thing about sustainable aviation fuel is it's a drop-in fuel, so you don't require any change to airframes, turbines, fueling systems, or any infrastructure around the airports and the airplanes, which is a key aspect to this. And SAF is proved globally for use in commercial aircraft up to 50% blend with fossil Jet A1. Without carbon capture and storage, it can achieve 70% greenhouse gas reductions. With CCS, it's significantly in excess of 100%. So you can end up with some sort of 30 to 40% of SAF in the wing and fly carbon neutral. And that's a real paradigm shift in the way that we can start flying. So moving on to, just continuing on that line, the air quality advantages. You can see on the right sort of pictures of Fischer-Tropsch SPK, well, it's actually diesel that we were making at that time. And you've got the picture on the left is our synthetic fuel burning, and on the right is fossil fuel. You can see the significant amount of carbon and particulate being combusted on the right, and hence all the smoke. So SAF burns particularly cleanly. I mean, there's a 90% reduction in particulate matter in the emissions, and around 10 parts per billion, virtually no sulfur. Whereas in fossil fuel, A1 jet fuel, you've got some significant amounts, 200 parts per million. So it's a significant difference in the sulfur content, and therefore the sulfur dioxide that's emitted in flight, which is a significant pollutant. As we said earlier on, it's ASTM registered to be able to blend up to 50%. And these are key aspects to why SAF is so popular. In terms of what in our product, our process, we're using our Fischer-Tropsch process to take these abundant feedstocks, MSW in the project in the UK, but municipal solid waste is everywhere. And in the UK, Alto will divert some 600,000 tonnes a year from landfill, out of a total of current about 11 million tonnes being landfilled at the moment. And of course, generate significant gate fee revenues for that project, and will for further projects as we go forward. In terms of the other projects, we use the clippings, trimmings and thinnings from the forestry industry in terms of it's a byproduct from the forestry management for the timber and paper industries. Vast volumes available globally with a high carbon content and a homogeneous quality. In the US, obviously, we sustainably source it from managed forests. So these two are the key feedstocks for our process. So what does our process look like? It's the integrated technology solution provided by us starts at the bottom left with the biomass waste coming into our feedstock conditioning facility, and then is fed into a gasifier. It's pre-treated, the feedstock's dried and shredded to size, to then go into gasification, which is the substoichiometric combustion of the biomass, which means basically it's not burning with sufficient oxygen. So the syngas that comes out is high in carbon monoxide and hydrogen content, rather than being all H2O and CO2, which if it was, it completely combusted. We're using a combination of suppliers. TRI provide us with the gasification. The cleanup system is a combination of Linde, Arvos and Air Liquide, providing us with then a very clean carbon monoxide and hydrogen gas that goes into the Fischer-Tropsch process over our very highly reactive catalyst that takes the carbon dioxide and hydrogen and turns them into long-chain hydrocarbons, which then go into a hydrocracker, which we get supplied by Halde Topsoe to produce finished fuel, which is sustainable aviation fuel and naphtha, some 70-30 in terms of volumes. Worley are our engineering partners, coordinating all of the engineering on the integrated technology package. On the right there is an example of our reactor. It's one of the ones that we sold into Red Rock last year. They're about 2 meters high and about 5 meters long. There's no sort of way of working out how big they are. There are 4 basic microchannel reactors with the cores inside that vessel, which is really the secret technology that we brought along with the catalyst to the process. We've demonstrated the technology. We've got a number of patents around the superactive catalyst and making commercially competitive using that microchannel reactor, which the key about the microchannel reactor is it's a kind of a bit like a radiator, a car radiator. It takes the heat away and maintains a consistent temperature around 205 degrees for the catalyst to operate for long periods of time. And clearly it's compatible with the other technologies that we've just talked about in the end-to-end process, producing these drop-in fuels. It's a compact design, which is great, and it's modular, so you can have a number of these side by side, coming from taking significant quantums of the syngas to produce the FT products going into the hydrocracker. So the first completed demonstration project was in the Oklahoma City in 2017-18. We completed just over 6,000 hours of cumulative operation across 2 reactors, taking natural gas or landfill gas and converting it into FT products. And we produced some 1.6 million litres of finished fuel and wax delivered to customers. It's wax at room temperature, but at heated it's a liquid, and that's how you transport it. We stress tested our equipment and the technology during this period, and was a culmination of all the work that we'd done previously and getting these reactors in the field, in operation, with third parties managing that operation. In terms of, I think Henrik has covered some of this already in terms of our reference projects. Got the Alto Alto project, that's a 3D picture of what the project will look like up at Immingham. We got British Airways as a co-investor into the project, receiving planning last year, and project construction will be financed 100% by third parties. This is the hybrid capital light business model that we're pursuing, with a view to starting construction in 23 and full commercial operation 3 years later. It takes about 2 to 2.5 years to construct and up to 6 months to commission. So we'll be in production in 2026. And as Henrik's already said, this will take 600,000 tonnes of municipal solid waste, MSW, into 70 million litres of fuels, around sort of 45, 50 million litres of SAF, and the rest will be naphtha. The other reference project that we have is the Biofuels Mississippi US project. You can see there in the top left-hand corner, it's on the banks of the Mississippi River, in a low-lying area cut off by a big levee. We have all of the necessary support and utilities around the plant, and we'll be able to bring in 1 million tonnes of woody biomass residue from around 70 up to 70 miles away around the plant, which will allow trucks to be able to do at least 2 deliveries a day. It's a great site. The nameplate capacity will be 30 million gallons per year. It's about 50% again in terms of production than the project in Alto Alto in Immingham. We have a number of partners already in the project. Occidental have partnered up with us to take our byproduct of CO2 slipstream from the process and sequestrate that in a local gas aquifer. And this is the key to getting the deeply negative carbon intensity score for the project, which when we sell the SAF into the Californian market, gets significant revenues from the low carbon fuel standard credits that we will get in California. So a really double bubble, both in terms of what one can do with the fuel, and then secondly, the revenue streams that the project itself or the fuel buyers will actually obtain. So in targeting feed launch end of this year, and we're working with US government on loan guarantees and with funders to fund the feed coming in at the end of the year. In terms of other projects, Red Rock, we supplied them last year with 4 reactors. They raised some $400 million for construction finance for their project, with support from the US Department of Defense with a 70 million grant. We've licensed our technology to them and supplied the reactors and catalysts, and we're now expecting them to commission and get the plant operational at some stage in early 22. The output of the plant is about 15 million gallons of renewable, of SAF, diesel and naphtha. So that's a great success to be able to have supplied into a third-party project. And we look very much forward to helping them with commissioning and then leaving them to operate their plant using our technology. With regards to Toyo, I think we've already had a little bit of background on Toyo. Their demonstration project was very successful last year, and there will be potentially some use of SAF from that project in flight at some stage this year. We've secured an agreement with them, a collaboration agreement, and then latterly a more detailed engineering agreement to complete the pre-feed work, which we've now done. And we should be going into feed for this project later on this year. It's a commercial project of the similar size to the Red Rock project. And that, I think, is all that we've got on the slides for today. I think we now move, Henrik, onto questions.
Right. Thank you very much, Andrew. And we open up the floor for questions.
Absolutely. Andrew, Henrik, thank you very much indeed. Ladies and gentlemen, do please continue to submit your questions using the Q&A tab situated in the right-hand corner of your screen. But just while the team take a few moments to review those investor questions submitted already, I'd like to remind you that recording the presentation, along with a copy of the slides and the published Q&A, can be accessed via your investor dashboard on the Investor Meet Company platform. I'd also like to remind you that your feedback is important to the company, and immediately after the presentation has ended, you'll be redirected for the opportunity to provide that feedback in order the company can better understand your views and expectations. Guys, perhaps before we move on to the live Q&A, we had several pre-submitted questions from investors, and if we can start the Q&A session off with that. The first one, I think I'll address to you, Andrew, if that's okay. It reads as follows: is there a possibility that VELOCYS may receive further payments in relation to F4C?
I nearly answered this question in the presentation, actually. Yeah, I mean, the F4C, we received early monies for the F4C because it's really for construction funding. So we expect to be able to obtain additional funding from the F4C at a later date. We've got the final payments. We made the final application for the grant. The grant period ended in March, so we should be receiving any minute now the final payment from them for the final piece of the 500,000 any moment. We are now, as we've said previously in public domain, finalising the application for the Green Fuels, Green Skies grant that the government announced. They actually announced it in November last year and put out the call in late March, and so we will be making an application to that by the end of this week. So that'll be a grant that'll help us with the next stage of Alto. should be some millions of pounds coming to us for the work around the feed and some of the other aspects of the development itself on the commercial side. Hope that was helpful.
That's fantastic. Thank you very much indeed. And the next one, Henrik, if I can address that to you, what are your hopes in relation to COP26 and the UK government policy?
COP26 helps to focus the minds of everyone to move from sort of broad policy statements to actionable decisions and legislation. I think everybody expects that to happen now. The UK government seems determined to issue actionable legislation that helps to get projects such as Saltalto and others funded. It's long-term capital we obviously need. These are 20-year assets. There's plenty of capital out there looking for these kind of investments, but the revenues have to stack up. There has to be certainty, has to be support. The UK government has a fantastic track record and template and model for how this needs to be done. The offshore wind industry is a global success in the UK. It was not initially, but once the UK government launched the CFD price mechanism for offshore wind power, the industry took off. Capital flowed into the industry, scaled up, and the UK became a global leader in that field. There's no reason why the same can't happen for sustainable aviation fuel, and the political desire seems to be there. It has all the other positive effects also, possibly even more than wind in terms of creating employment onshore, long-term, well-paid employment onshore in various roles from skilled to unskilled. So I think the government, it fits kind of all the different boxes for the government in terms of what they want to do now in leading with decarbonization, but also creating economic growth, international competitiveness, upskilling and leveling up the country. So I'm very confident the UK government will use COP26 to announce progress in this area.
That's fantastic. Andrew, Henrik, thank you very much indeed. As you can see, investors have submitted a number of questions during the presentation. If I may just hand back to you, just to click on that Q&A tab, and where appropriate to do so, read out the question and give your answer. That would be fantastic.
Right. Okay. It's a very good set of questions. Quite a few of them. Let's see.
I can answer one straight away.
Go on. Yeah.
Can you explain the relationship between revenue recognition, working capital, and the cash profile of a project? Revenue recognition occurs when the conditions surrounding the supply of goods and services, all conditions have been met, and then you can recognize the revenue. The cash, on the other hand, comes in when shortly after invoicing and in terms of the T's and C's of the invoice. So revenue recognition doesn't mean cash. So the cash profile is usually, once we've done some work for somebody, we invoice them, and generally we invoice up front for equipment, some sort of 30-40% up front, some interim payments, final payment, and then a little bit more on mechanical completion. With regards to engineering, generally that's invoiced on a monthly basis and paid on a 30-day period. So revenue recognition can mean that, as we have with the Red Rock order, a significant amount of all the work that we've done for them piling up onto the balance sheet, and then you recognize it and put it onto the income statement and through that way. So it's a slightly sort of accounting way of managing our revenue and balance sheet. But actually, in terms of cash flow, it has no effect at all. The cash flow comes from the customer in accordance with the T's and C's of normal invoicing.
Let's see. I have a question from Alan here. Planning permission in place. Why will it take a further period to begin construction? Now, large capital intensive projects typically spend 5, 6, 7% of the total capex in detailed engineering before you break ground. That might sound like a large amount of money, but anybody who tries to do it for less than that or quicken that will normally regret it deeply, because you make any mistake that you can spot and improve and sort out on the drawing board vastly cheaper to rectify there and then rather than during construction. During construction, everything has to be already worked out in the finest detail, and the long lead items need to be ordered already a long time ago and arriving just on time, modular, etc. So it is industry standard and vastly more efficient to prepare a complicated, advanced, complex construction project like this extensively before you break ground. Now, quite a lot of that detailed engineering is not realistic to do until you have planning permission. As we all know, in the UK, it's very, let's say, uncertain if you get planning permission for any or no reason. Lots of things can happen that delays or even prevents planning permission. So therefore, it would not be responsible for us or anybody else to start a serious work of detailed feed engineering until the planning permission is received. So hopefully that helps a little bit on that question.
We've been asked another question on UK policy support, Henrik, in terms of how it's going to develop and support a negative emissions project at Alto Alto. I think the UK policy support that we are lobbying for currently is to get the UK government to support fuels in the way they support the production of power via a kind of CFD mechanism. Originally, power was supported using the ROCs mechanism, renewable obligation certificates, in the same way that we have renewable transport fuel certificates. What we want is the change via a feed-in tariff type system to CFDs that will ensure that we've got some certainty to the revenue stack, similar to the offshore wind farms, and you can see the developments that have occurred in wind should then lead to the similar thing happening in the fuels market here in the UK. With a negative emission via carbon capture and storage, again, we need to make sure that, as in the low carbon fuel standard in California and in other states now coming up in USA, that as you get more negative, and you should get rewarded more effectively. And so that's something that we're keen to pursue with the UK government.
Indeed. Thank you, Andrew. There's a good question here from Zain. Maybe we should clarify the Green Fuel, Green Skies grant. You can see that in the language describing the eligibility for applicants. The way they describe that is very well, let's say the Alto Alto project fits very well with the criteria that the government outlined for that grant competition. And nothing is ever a guaranteed win. I see the question here. We are humbly applying for the grant. We feel good and confident that we will be awarded all or some of it, but obviously a government grant competition is totally in the hands of the government to decide to award or not to award to anyone. So nothing is of course guaranteed, but the characteristics of the Alto Alto project seems to fit well with the criteria for the applicants that are invited to apply.
There are various questions that talking about the projects and what we're doing in terms of offtake. Rather than answering a specific question, there have been a number of different types of question on this. In both UK and US, we are talking to people about offtake from the project. Clearly, British Airways are a partner to the UK project and have rights of offtake from that. In the US, clearly a year ago with airlines all shut down, they weren't too happy to chat about SAF offtake from 2025 onwards. However, things have changed dramatically, as Henry pointed out earlier on. The situation now is that we are talking to a number of off-takers for SAF in the US, not just airlines, but also fuel supply companies, refineries, and it is getting extremely busy in the United States for discussions for offtake from our reference project in Mississippi.
Yeah. I can see some questions about the speed of development of our reference projects, i.e. the adoption of our technology. I would say it's refreshing to have Helen Lillemore join us. She's financial director from Shire. Came in and joined us the middle of last year. In the pharmaceutical, in the biotechnology area, normal product development cycle, 10, 20 years, hundreds of millions of dollars or pounds at risk in capital. All the companies in that sector spend their money on a number of projects that are very uncertain. You have significant milestones, the demand, the approvals, the permissions may or may not be there. And after 10 to 20 years, you find out. And when you find out you're successful, the technology makes a lot of money for the shareholders who have been patiently supporting it over the years. Some do, some don't. So what we produce is not biotechnology, but it is a complex conversion of biological material, biogenic material, into long chain hydrocarbon molecules that are almost medical grade in terms of how clean they are. So that is always going to take a long time. It is remarkable the fact that our product can be blended straight into the current fuel pool. We don't need customers to change their technology or adopt the fuel. The adoption of the fuel will be automatic in the sense that it gets blended straight into the pool. But the technology needs to be adopted by fuel producers, of course, who need to be sure that it works, that the technology readiness level is there, it's demonstrated in lab and pilot scale and full scale. So I would say there's nothing surprising about the time scale that we've been working over. And the demand is there now. So I'm confident that we will achieve that breakthrough. We have received sort of the difficult to receive kind of permits, such as the UK planning permission is a difficult permit to receive. We have received permits and approvals and secured sites in the US, and it looks very good in places like Japan as well. So we've come a very long way away, but the fact that it's taken between 10 and 20 years is not surprising to me at all. All right, can we move on to, we have a number of other good questions. Let's say here, anaerobic biodigesters to produce methane as a feedstock. Good question by David D. This is one of the things that attracted me to VELOCYS, our technology, the feedstock flexibility. The fact that our technology is well suited for conversion of a combination of hydrogen and carbon monoxide into liquid fuels, clean liquid fuels, regardless from where it comes from. So depending on where the location of the particular proposed site is, a combination of forestry residue, agricultural residue, or municipal solid waste residue, or indeed biomethane can be used to be gasified, or in the case of biomethane, to be reformed, easily turned into hydrogen and carbon, and then with our technology synthesized into clean, sustainable fuels. So it is a fantastic versatility of our technology that allows the integrated plants to be fed or co-fed with a number of different types of feedstock, including what is potentially the most exciting pathway of it all, which is 10 or 20 years down the line, but it's power to liquid, where we obviously already now, there are demonstration projects and projects in underway where we are involved and been asked to provide the central synthesis technology for processes where renewable power is used to electrolyze water, creating the hydrogen that way, and then via direct air capture, capturing CO2 directly from the atmosphere, synthesizing those two molecules into fuel, which therefore becomes the ultimate endless source of fuel for forever if proven efficient and economic in the end. We are a long way away from there, but countries like Germany, Switzerland, and other in continental Europe in particular, there is a huge effort to accelerate and demonstrate the potential of so-called PTL. But in all these different conversion technologies, a modular, compact FT synthesis is required of the scale and size and nature that VELOCYS has. So we are well fitted into all these different types of feedstocks and pathways to generate the carbon and the hydrogen in gas form, which then gets synthesized into liquid fuel. So it's thank you for that question. Not many people in this country talk about biomethane, but across Europe it is very, very hot topic, and the supply of biomethane is increasing dramatically via the anaerobic digesters.
We've got a question from Adam. How many projects can the US forest resource support? Significant number. I mean, we're only taking 1 million tons of feedstock from the local area, just up the river. A pulp and paper industry mill has shut, and that was taking 4 million tons of wood chips into the process. So significant numbers. We haven't sat and tried to work it out exactly, but it's a lot. One of the interesting things, statistics that I've noted since been down into the southeast of the United States in the fiber basket, as they call it down there, is that the growing period is significantly shorter than elsewhere. It's like a tropical rainforest in parts, in that the growing time for a full tree in southeast United States, 25 years. In Northern Europe, it's 50. So there's a considerable difference between the growing periods and the amount of wood waste and forestry waste that occurs that would need to be taken off from the forests for our process. So significant numbers, I think, is the answer. We haven't sat and worked it out because the numbers are so large that we don't need to worry about it in the short term. We need to just get these first project off the ground, and then the plans for the following projects as soon as possible.
Thank you, Andrew. A quick question on the Humberside region. There's a great movement ahead now with this could create one of the, I think, 4 announced national CCS clusters. So the Humberside is one of the leading contenders for that, and we are, of course, actively involved in creating with some large partners and being sort of part of the suppliers into that CCS cluster. What is very, very attractive with the Alto project is that we would be injecting biogenic CCS that becomes sequestered into the aquifers. So we're taking, therefore, indirectly, but still CO2 out of the atmosphere and sticking it into the geology, which is very, very attractive, as opposed to those who are going to be capturing CO2 from combusting fossil fuels and sequestering that as well, which is also good. But it's even better to contribute biogenic CO2. And the Humberside looks like the most advantaged site in the UK for that purpose. And that opens the way for negative carbon intensity fuel, i.e. where the net life cycle effect of the fuel is that we are taking away CO2 from the atmosphere, and it ends up on balance reducing overall post-combustion the amount of carbon in the atmosphere. Any other question, Andrew, that you think we're able to answer at this point?
I think, guys, you've done a fantastic job. You've got everyone you answers, another one seems to come in. But as we are just coming perhaps up to the hour, obviously the company can review all questions or any further questions that are submitted today, and we'll publish responses where appropriate to do so on the Investor Meet Company platform. Henrik, if I could just ask you perhaps just for a few final words to wrap up then on that basis, and before we redirect investors to give you some feedback.
Well, I am very grateful for your participation today. I think the quality of your questions were very high. As professional investors, many of you are aware there are certain types of questions we cannot answer, of course, because of we're listed stock market entity that have to abide by the rules of public disclosure. But your questions are insightful, demonstrating that you do understand the nature and the long-term nature of the opportunity here for VELOCYS. I would just end by saying that the level of support and intensity in the demand here has just started. I think I would draw attention to the announcement by British Airways and the IAG relatively recently, where they committed to using 10% of their global fuel demand supply must be SAF by 2030. That's less than 9 years away. That's a huge amount of fuel that needs to be non-fossil by then, just by BA and IAG. That would be the same as a number of plants, a handful of plants of the size of Bayou and Altalto, just to supply the SAF that is required by the IAG group. So put things in perspective, these airlines, these major carriers like BA need to be involved and secure at this point offtake from a significant number of plants of this kind of size in order to meet their commitments that they have made themselves, but also that will be mandatory. Most likely there will be mandates committing all airlines to decarbonizing and phase out fossil fuel from their demand reasonably soon. So that is each airline needs to secure offtake from more than one project of the size that we're talking about here. Each of them, if not a handful. So this is just the beginning of a long, many decades of growth, which personally makes me incredibly excited about our technology. One of the strongest questions also here that we are focusing on is the length of our IP protection. Thanks to our demonstration in Oklahoma and other demonstration work, we have got those reactors back at our technology center, allowing us to use the evidence of those operations and changes to file extension and renewal and improvement patents, which automatically extends our maturity of our patent portfolio significantly every time we file improvement and improvement patents around our core technology. So we have no problem to defend and maintain a maturity of patent protection that is required to support our position in this industry for a very long time, thanks to our intensive demonstration and continued development work with our partners. But good, thank you for that very good question. We're super focused on that.
Henrik, thank you very much. Andrew, again, thank you very much for your updating investors today. Could I please ask investors not to close the session? You should be automatically redirected for the opportunity to provide your feedback in order that management can better understand your views and expectations. This will only take a few moments and it will be greatly valued by the company, so please take the time to do so. On behalf of the management team of VELOCYS PLC, we'd like to thank you very much for attending today's session. That concludes today's presentation. Thank you and good morning.
Thank you very much, everyone.
Thank you.